Wow, this conference has grown quite a bit, I must say. Very welcome to my talk today, and a warm welcome as well to the Spring I/O conference from my side. I will talk about a topic that's, I would say, quite popular nowadays in terms of microservices and stuff like that. Everybody is always talking about domain-driven design, and I assume that most of you are aware that domain-driven design contains not just technical stuff, but also some organizational stuff and I would say political project culture stuff. This is not what I'm going to talk about today. Today I want to focus about the implementation aspects of domain-driven design. I mean, there are a couple of things to consider when you want to adopt domain-driven design in your projects, and some of those things may come in handy for you. Others may, you may have a gut feeling that they may not be as suitable for you. And I will guide you through a couple of those questions, and I will show you a couple of slides with theory, and I will mix that up with code all the time. So there's also a project on GitHub that reflects the stuff that I'm talking about in this talk today. And yeah. A general disclaimer from my side. I can highly recommend to everyone the books by Eric Evans and Vaughan Vernon, and I have to give them all the credits they deserve for those fantastic books. So a lot of those ideas originate from those books, like the bounded context, the aggregate, and stuff like that. Here and there, I'll add my own grain of salt to the mix. And this is the most important disclaimer. I think it was shown last year already at the Spring I/O conference by my good friend Jochen Mader from Germany. Please be aware that this stuff that I'm talking today is highly popular. But unfortunately, what I see in many projects is that a couple, for instance, the internal building blocks of DDD get forced upon problems that they are not suitable for. So please make up your mind and make up a decision if the stuff that I show you today is suitable for your problem or if it's not. Nothing of this stuff is a silver bullet, nor is DDD, nor Spring and stuff like that, as much as we all love the Spring ecosystem, obviously. Now, I will talk about, in this talk, first of all, I'll start with the bounded context. Dave already mentioned this term in his keynote right before my talk. Obviously, if you go for microservices, thinking and modeling with bounded context is obviously a good idea. So I'll lead you through that a little bit. And we will look at internal building blocks, like the aggregates, the entities, the value objects, also domain events, and we will mix up that with stuff that the Spring ecosystem helps you with. I mean, there are many fantastic technologies, stuff like Spring Data, Spring Cloud Stream, Spring Boot, and so on. But also, and I really want to mention that, this one, good OO practice. So a good practice in terms of object-oriented development. Now, let's start with the bounded context. Especially when you want to work with microservices. One of the, a major term that we often hear is model your microservices along business capabilities. Now, when you want to work with Spring Boot-based microservices, leveraging technologies from the Spring Cloud portfolio maybe, you still, that's the technological side. But if your microservices are highly coupled on a business level, all the fancy technology won't help you. You're still screwed. So please keep that in mind. And this is where the strategic design part of DDD helps us. So most important, the bounded context and the context map. I will not talk about the context map in any detail today because it would be too time-consuming and not in the scope of this talk. But let's start with the bounded context first of all. So basically, every sophisticated business domain consists of, well, some boundaries. Those can be linguistic boundaries that, let's say, an account. We have a bank account and we have a user account. They're both called account, for instance. We have a rating. That can be a rating from a credit agency. That can be a rating from an internal scoring process, for instance. Now, those things are a little bit different, I would say. And each of those bounded contexts contains a domain model that we have to implement. And this is the most important sentence about that topic. It's the boundary around the meaning of a model. Now, let me show you a quick example. This example is about all of you in the audience. So you are here at the fantastic Spring I/O conference in beautiful Barcelona. And Sergi and his amazing team, they set up this conference, they ramped it up, they organized it. So obviously, they needed to know how many people are coming. Is it going to sell out? Yes, it's sold out, which is fantastic. So who's coming? Did everyone pay their fees and stuff like that? Then we need to manage the event. We have a couple of different venues here. We have like this big room over there. We have a couple of smaller rooms and so on. Now, who is going to do a presentation in which room? Which speakers are extremely popular? Which topics are extremely popular? And finally, you all have your badges with you. So those are those things over there. We all have them. And now this is where we all come into place. So that's the Spring I/O visitor. Obviously a software developer, CD pub, more beer on the shirt. And how do we model the customer? In the typical service-oriented architecture world, we would say, we need one customer service. That's the big, fat web service that everybody needs to integrate with. Everybody needs to work with the model. And obviously, this reservations context would have a sort of a model that can be suitable in this case. Now, the event management part has more a numeric model. We don't care if, let's say, you in the first row want to go to the DDD talk or to some other talk that's running in parallel. We don't care if you in the first row are a vegetarian or a meat eater. It doesn't matter. It's just like occupied seats. So we just think about numbers. And in terms of the badges, we can consider having replicated or shared data, replicated or shared behavior. Obviously, the microservices world wants to go for replicating, so not sharing a lot of the stuff. So basically, the bounded context is the boundary around the meaning. So first thing first, inside of a bounded context, I want to stick to the good old mantra, don't repeat yourself inside of a bounded context. But outside or between bounded contexts, I may consider explicitly repeating myself for the sake of decoupling. Now, that's about the bounded context. That's more, I would say, a logical kind of thing, a way of thinking about architectures. And I have mentioned the term microservices quite often, but this doesn't only apply to microservices. This also applies to monolithic applications as well, because you want to have an evolvable system. So I could have, and I actually think I should have, written systems should be evolvable. And DDD offers us one set of patterns, the so-called internal building blocks from the tactical design part of domain-driven design. Now this is where our aggregates live, where our entities live, where the value objects are located at, and the factories, the repositories, and the services and the stuff. This is like the classical DDD kind of approach. Now, I will go through that, and we will see how we can implement those things. First, on a general side, then we will add a little bit of Spring here and there. But please be aware, and I will come back to that later on. Not every bounded context may be suitable for those patterns. I will come to alternatives later on. Now, I will mention them first because they are like the classic DDD patterns. Now, let's start with the entities. The entities are your core business objects. So please think about business and not data objects here. of a domain. They have a constant identifier, which isn't necessarily, or hopefully, your database primary key. You want to think about business keys in this case. And they have their own life cycle as well. On the other hand, we have value objects. In terms of the value objects, we usually don't think about like real identifiers or stuff. We think about the identity derives from a combination of various attributes of a thing. Let's say this presenter costs 80 euros. So this monetary amount, the 80 euros, we just care about 80 and the currency euros. We don't care which 80 euros those are. So that's a typical value object. And eventually, someone has spotted the bug, or the not-so bug, in my slides. I mentioned the customer twice. We have the customer here, and we have the customer over there as well. Now, what's the customer? Is it an entity or a value object? The answer to that question is the best answer you can always give as a software architect. It depends. And it depends on the context, on the bounded context. You will have some bounded contexts where the customer is an entity, and it is rightfully so an entity. But you have other bounded contexts where the customer may not be an entity, where we just care about a couple of values, and we're good to go about that. Now, one thing that I see very often in code reviews that gets mixed up quite a bit is we have the entity in JPA as well, don't we? So if you look at the JPA specification about entities, and if you look at the DDD books into the chapter of entities, you find a parallel. Yeah? Each JPA entity must be annotated with an @ID, for instance. It has an own lifecycle. It's a part for most of the operations on the entity manager. So, and it's called entity as well. But as I said, we can apply the concept of bounded context to that as well. Different context. One is a data entity, the other one is a business entity. So, as a general rule of thumb, please don't go ahead and mix up your DDD and your JPA entities. Those are two different kinds of things. One is behavior, logic, and so on. The other one is data. Now, in order to group all those things together, there is another pattern in DDD called the aggregate. And I am a big, big fan of the aggregate. I think aggregates are really amazing, because they group entities and value objects together. And if you look at the literature in terms of DDD, you see that there is a little bit of an evolvement over the time. I mean, DDD is nothing new and fancy. I think Eric's book came out 15 years ago, as far as I know. So 15 years, that's an eternity in terms of IT. So think back where the Springboard was 15 years ago. Quite impressive. And both stayed relevant. So we're talking about two old and classic things today. Basically, nowadays, most of the people I talk to, and I go with that opinion, they prefer rather smaller aggregates. And it's totally okay to have one aggregate just referencing value objects. And it should just be, most of all, be a boundary around things. And there are a couple of rules. You may have seen there is a new thing here, the root entity here, this one over there. Now, what is that root entity? That root entity can be a lifecycle override over other entities. But it is also the entry point into an aggregate. So you wouldn't be allowed to enter this loan application form aggregate through the loan, for instance. You would always have to go through the loan application form for that. And there are a couple of rules of thumbs and best practices for aggregates. The first one is keep them small. Reference them by identity. So please don't go ahead and build big reference graphs between aggregates. I will come back to that with an example in 2 minutes or something, where we see that very explicitly. And make them a consistency boundary. Make them, ideally, you should have one transaction over changes on one aggregate. This leads you to a very high degree of decoupling, and this comes in extremely handy when you want to build monolithic applications. I mean, microservices are a great thing, but there are a couple of use cases out there, or a couple of organizations where microservices may not be the best use case. That would be better off with a monolithic application. I mean, a monolith per se is nothing bad. Only a badly messed up monolith is something from the gates of hell in order to maintain. But this can lead you to maintainable code, to very robust code. Now let's take a look at some implementation aspects. I want to start with an example first on a battery of an electric car. So we have a charger in there. We have a couple of cell blocks. We have some projections on it, a status, some general information, and so on. Now, one of the classic practices, which I don't like quite a bit in the Java world nowadays, would be to go ahead and make everything of these things private and expose public getters and setters. I call that the shortcut from hell. And those getters and setters are public. Very easy nowadays with Lombok, with shortcuts in IDEs, really easy to do that stuff. But basically, this is against information hiding. You're not doing information hiding in this case. You are exposing everything to the outside. And think about what the external access really needs to be, what you really want to do with that. And the code that I'm going to lead you through now, I will switch now to the code example, to the code part, is on GitHub. It's a work in progress. It's not perfect yet, I'm aware of that. But I think it sketches out the ideas pretty well. So if you want to follow that project, if you want to contribute to it, be my guest. It's Apache 2 license, so easygoing for everyone. And let me show you the application as it is right now. So basically, this application consists of 3 Spring Boot applications, basically. It's a credit application implemented by this pug over there. And we can fill out, and let's start with doing that. Let's start an application while I talk. We can fill out a loan application form for mortgage loans. So obviously, we have one bounded context, a credit sales funnel. Now, think about a credit sales funnel, what the most important things of this beast are. It's about capturing data, writing down stuff, and doing things. Yeah, it's filling the stuff out right now. Somehow it's a little bit slow. I don't know for which reason. Let's cancel that. Now it's speeding up. Very nice. And the stuff that you want to do over there is you just want to capture data. Now, would the aggregates be a suitable model for this one? I'm not so sure about that. But there is another context that might be very interesting, the scoring. So this application contains a rather sophisticated scoring engine. And the scoring engine runs as soon as we have submitted an application. Now, let's add some more things. Let's say 1978. And we start working at the 1st of 2017. And now we can submit this thing. I'm not going to do that now. The scoring part is basically structured like that. It contains 4 aggregates, and I will show you them in code right now. Now, one thing is they are all, I would say, the applicant and the financial situation, they come obviously from this application form to a certain degree. And then we have another aggregate, the agency result over there. That's this thing over here. And this comes from a 3rd application from an external credit agency which delivers us some information about the creditworthiness of customers. Now, the interesting part is this credit agency does know nothing about our application, about the application form, about the number of the application, the business key of the application. So it only thinks in persons: first name, last name, street, postcode, city, eventually birthday. And that's the thing over there. So one way that we could hook up the applicant with the agency result would be that the agency result references an applicant, or that the applicant references an agency result. That's one way of dealing with things. But we would hook up those things quite closely together. Another way is adding a new value object to it, a person ID, which is only suitable in the scoring bounded context, and both reference this person ID. And then we finally have the application number, which is the application, and this hooks up into all of those things and brings them together. Now, one hint from my side in terms of implementing: you can go either on an implementation level to go directly for a root entity, or for an explicit aggregate class. In my example, I will stick to the explicit aggregate class, but there is also another way of doing it, and I will mention that. Now, the first thing in terms of Spring is keep your aggregates Spring free. Don't build anything regarding Spring into your aggregates. This should be plain old Java. Let's go to the code. So this project consists, as I mentioned, of 3 sub-projects: the credit agency, the credit sales funnel, and the scoring engine. Now, the scoring part contains one module called Aggregates. I will come back to the other ones later on. Now, those aggregates, they are all the 4 aggregates are placed into separate packages. Please do so, really do so. And why? Because I like to work heavily with package visibility in terms of information hiding when I work with aggregates. Now, I will show you a UML diagram of the financial situation, for instance. Okay, then it's wanted to have the financial situation. So let's enhance that a bit. Make sure that we see everything, yes, and I want to have the relationships, and let's clean it up a bit. And now let's zoom in there a little bit. So the first thing that I have over there is my financial situation aggregate. And this contains a root entity, which is my financial situation root entity. There are options where you could also toss away the aggregate and work with the root entity directly. This is also a very popular option. So I don't think there is a better or worse between the two. Make up an educated decision what you want to have. I want to have the aggregate semantics encapsulated in an extra class, but you could also do that on the root entity as well. What the financial situation aggregate then refers to is the root entity with outgoings and incomings. So there's rent, there is some cost of living, there is some salary, and we have a builder. I think the builder aggregate, the builder pattern goes very well hand in hand as a substitute to the factory of DDD, especially when you work with aggregates. Now, one interesting thing about this diagram is that's the complete internal view. Now, from a public point of view, let's see what's publicly visible. You see, outgoings are not visibly public on a public level. Incomings are not visible on a public level. The financial situation root entity are not visible on a public level. They are hidden. How do I do that? Not every class has to be publicly visible. You can work with package protections on a class level. So no one from the outside of that package can mess around with these things. The same applies to the financial situation root entity. I'm even hiding the root entity. The only public visible is in my aggregate class over there. And do you see any Spring import there? No, no, no. Incomings? No, nothing. This is plain Java, but it's away from the get-set semantics. Now, what I have done here, and the same applies to the applicant. Let's take a look at the applicant root entity, and so on and so forth. Now, think about that. Now, what about testability? This code is easily unit testable. Just place the unit test in the same package as the aggregate, and you can test out all of the details. You don't need a @Spring Boot test in order to unit test that. I mean, you should always write your components that you only need the Spring Boot test for more sophisticated integration testing. But this is perfectly unit testable code, and it hides a lot of the outside. Now, what I have added to my applicant aggregate over there is an annotation aggregate and an annotation aggregate builder. And I put them into the microarchitecture module of this bounded context. This only exists in there. Why? Because I want to have an architecture, a code quality management in place that checks if aggregates are publicly visible and that other classes that are not aggregates are package protected. Now, a quick question in the round. Who ever heard of a tool called ArcUnit? Yeah, quite a few hands. This is your new favorite tool. ArcUnit is awesome. ArcUnit is a unit test tool for software architectures, and it contains a really amazing Fluent API. Now, let's take that. Aggregate annotation rules. Classes that have name matching with aggregate should be annotated with aggregate. Classes that are annotated with aggregate should have name matching with aggregate. So the same rule, vice versa. Another thing is classes that are annotated with aggregate should be public. Classes that are annotated with aggregate should access classes that have name matching root entity. So the aggregate may only reference the root entity. And this is something you can easily run as a unit test. And I highly recommend you, if you want to follow that path in terms of the aggregates, that you use a tool like that so that nobody cheats around. So let's go ahead and just remove the applicant aggregate. Let's remove that annotation. And let's rerun the test. Boom. Aggregate annotation rule. Classes should be annotated with aggregate was violated in one thing. Applicant aggregate is not annotated with aggregate. Isn't that amazing? It's called ArcUnit. Highly recommend that tool, especially for stuff like that. Now, if we move on, we need to work a little bit with the aggregates. When we've worked with the aggregates, they are obviously part of the core domain inside our so-called hexagonal architecture or onion architecture. This is an architecture that is not highly proposed in the DDD books, but well, Vaughan mentioned it quite a bit in his books, but not so much Eric. So, but this is an architecture approach that goes in hand very often with this way of thinking. Now, so far we only have our aggregates. And now let's take a look how we bring them to life. I mean, we need to persist a little bit of that stuff from the aggregates, obviously. We need to orchestrate them somehow. So far we only have the aggregates. And we need to have some kind of a communication from this credit sales funnel kind of thing to the aggregates. Now, let's first of all start with looking at application services. So in my project, I have a class called scoring application service. And this application service orchestrates through quite a few of the aggregates. So let's take a look at this one, score the agency result. So somehow an agency rating from the external agency comes to us, and we need to ramp up a new aggregate just for that. What I do with that is I use the builder pattern. And each aggregate that I implement has a builder. So we ramp up for a person with first name, last name, street, postcode, city, with some points, with some rating points. So the rating agency gives us a few points on the rating. And finally, I build the result aggregate. Now, going back to our slides, onto this one, we see that the agency result contains KO criteria, warning messages, and stuff like that. Let's see what's publicly visible. Calculate scoring points is acceptable, and please give me the person ID. This aggregate contains behavior. It scores itself. It has the scoring rules built directly into it. And that's all that I can do with this one. Now, let's go to another aggregate in there. Let's see where we score. Let's score the financial situation. You remember the financial situation aggregate, cost of living, other income, rent, salary, billed. And you remember we had the incomings somewhere. Can't see it. Why? Package visibility. So it's all hidden. And basically, the job of the application services is to orchestrate certain operations over various aggregates. And you see, we work with the financial situation aggregate. We work with the applicant aggregate over there. So, and they are both, after the application has been submitted, we can score them both. And I'll talk about the event publisher later on. Now, one interesting thing is we need to work with repositories somewhere. Now, in Spring Data, we have the Spring Data repository. Now, the thing with the Spring Data repository, if you use it directly, is it runs, let's just assume we work with JPA, because I think most of the people in this room do that. Who works with Spring Data JPA? Yeah. Quite a few people. So what do you put into your Spring Data repository? JPA entities. You remember? That shouldn't be your DDD entity. So we need to do something different. And a couple of folks who have also ramped up a very interesting project on GitHub on DDD examples came up with an idea that looks a little bit like that. I'll show you that example later on. So we have an interface for the repository, for the agency result, and I just store projections. I just store the results away after they get calculated. Then I have a data access object, which is basically then the Spring Data JPA repository, and I have an implementation of that. So basically, I'm working with just another repository class there that encapsulates the Spring Data repository. But the interesting thing is, mind the package. It's in the same package, but in a different module on my Maven build than the aggregate itself. So it can still get into the internals, because the repository very often does need to get into the internals. But only the repository is also in the same package, but I want to put it into another module for the sake of encapsulation and stuff like that. Now, we need to communicate a little bit. One thing before I come to the communication is, the hexagonal architecture is not your only option. So this is the option that I have just shown you. But if you take a closer look at for instance, the credit sales funnel microservice that I have in my application, that's just crud. You know, we just need to capture the form, write it to a database, and send it somewhere, and that's it. We're good to go. If you have that, maybe Spring Data REST or a context that doesn't run on business entities or aggregates may be totally suitable. And another kind of flavor that I often see is query-driven, query-based contexts. I'm sure quite a few of you remember some functionality where all the logic, all the knowledge, all the wisdom is in very sophisticated queries. And this is where the music takes part, not in Java code or something like that. And this can also, you should reflect that. And I always say, don't just stick to one thing and force it upon everything else. Go along other options as well, because in the end, and that's a quote from one of the DDD books, the domain should be the heart of the system. If your domain doesn't fit into an hexagonal architecture structure, don't squeeze it in there. Now let's talk about communication between bounded contexts. Now, obviously, we have a couple of options in terms of communication between bounded contexts. Sam Newman wrote that down really nicely in his Building Microservices book on O'Reilly. He differentiated between orchestration and choreography. I mean, orchestration is mostly synchronous calls going somewhere, and that's one part. But the DDD community nowadays is all about events. I mean, domain events are the hot stuff right now in the DDD community, and everybody talks about event sourcing, event storming, event-driven architectures, and choreography just turns around the call flow a little bit. So the credit application submits an credit application submitted event, and for instance, the scoring component reacts on that event. So basically, those event-driven applications are an interesting idea. And with that approach, you model your activity as a flow of discrete events. It's something that happened in the past, and you can work on the implementation side with various options now on the event payload. You can put the full thing into an event. I'm going to do that with the credit application submitted event. I just put the whole credit application, the whole thing that we have filled out in there and work with it. But you could also go ahead and put RESTful URLs to REST resources for the event, not your Spring Data REST repository, please, because events should always be immutable. You could have them empty so that you work with a polling mechanism, or you can mix things up. Now, in terms of infrastructure, what I see nowadays very often is like the first thing that comes around is, let's use Apache Kafka. But please make up your mind. Kafka or message brokers are not your only option that you can work with in terms of those things. In my eyes, you can work with a broker with HTTP feeds, which are really interesting. Who has implemented event-driven communications with HTTP feeds? Atom, RSS stuff? No one? Okay, I'll show that to you in a second. Or you can work with an internal event bus. And in terms of the Spring ecosystem, you can work with Spring Cloud Stream in terms of Apache Kafka or Rabbit. You can leverage Spring MVC, Quartz, or Roam in a combination to implement HTTP feeds, or you can work with Spring application events. Now, let's quickly take a look at all of those options, because they are all in the case study. Now, I will switch over to the credit sales funnel application. And what I have here is I have a credit sales web controller, and that offers me as we can see over there, this fancy button, Submit Application Form. And when I do that, let's see. Where do I have it? There we go. That's it. Submit application. So that's a post mapping. And it talks, in the end, to a credit sales funnels channel. So what you need to do in order to leverage that, in combination with Rabbit in my case, is you enable a binding, Spring Cloud Stream for RabbitMQ, add this channels thing here, which is just an output channel for things, and add a little bit of configuration for that as well. So basically, we bind that to a topic, and we tell the application, please serialize the stuff to JSON. On the other hand, for instance, the scoring has an input adapter, and it also has a configuration for that. It has a binding for the application process channels, which takes the application submitted in, and then on the incoming side, oh no, it's in the messaging, I have an incoming message listener where I just annotate the class with @streamListener. So when I click submit, the sales funnel sends me an domain event with that a new application has been submitted over RabbitMQ, and the scoring consumes it. The same is applicable to the credit agency. Now, that's one thing, that's working with brokers. Now, one thing that the credit agency offers me is a so-called HTTP feed. If we look at that, we have an HTTP feed with all new credit agency ratings. And as you can see in Firefox, this looks like the good old RSS world. And basically, it is an atom feed, where I put in some data, and the scoring polls that feed every couple of seconds. I think it's every 30 seconds right now. We can easily see that also in the source code, in the run dashboard. You see this select max stuff down there? That's exactly the feed polling that's happening from the scoring context. Now, on an implementation side, this is basically a very easy combination of Spring MVC, the Roam library, which is there in order to create RSS or Atom feeds, and basically it's REST with Atom combined. Just a brief look into this. Credit agency goes ahead, and we have the web, the person rating controller that offers the feed in the application Atom XML style. We set a last modified header based on the last updated rating, and we go for an REST Atom feed view, which basically is Roam coding. Hint from my side, just copy paste that, take it over, and modify it as you want. Now, on the other side, on the scoring side, as an incoming thing, we have a feed poller, the credit agency poller, which goes to that feed and polls every 30 seconds, but it leverages all the HTTP features that we have with the headers and stuff like that, and we poll in all the time. And now let's submit this application form, okay? And let's see. Now. Hello. Network problem. Could not. Oh, come on. Okay. It should have an updated one. Okay. I'll get back to that later on. I think it's with the Wi-Fi right now. That messed something up. But one last thing. In order to decouple across various aggregates, or various components in an application, we can also work JVM internally. So we don't go for a remote communication between the things. We go for a JVM internal thing. And there is a nice feature for that basically built into Spring, the Spring application events. And so what I have here, take a look at the application service over there. When I score that's the application event publisher. We publish an event, a scoring has been performed with a certain application number, and then there is, in this application, another component listening to that thing. Because we have two parts of scoring. We have the credit agency scoring, and we have the scoring of the application. And we need to get them both together in order to see that the scoring is finalized, because we need both parts. And I did that with the Spring application events. So basically, the scoring performed event extends from the Spring application event. I put in a little bit of a payload. And it's also very easy to implement a listener on that. That's basically, you write a Spring class, which implements application listener. You type it on a given event. And then you can do something on application event, and we can go back to the scoring application service and ramp up the final scoring and put that together. This is extremely handy when you want to build monolithic applications that are highly decoupled. You don't need to leave the JVM for that, or your deployment unit. This is a very powerful feature. Of course, it's not as decoupled as the Spring Cloud Stream stuff, but it's better than direct references. Right. Now, there is another project on the web which I definitely want to recommend. I didn't contribute to this one, but I took out quite a bit of an inspiration from that. It's github.com/DDD by examples. And they have a couple of different DDD examples. I mean, we could do a 2-day workshop just on the implementation stuff. I just wanted to give you a couple of ideas and input on these things. That's very useful. And to ramp it up, I'm currently writing a book on domain-driven design. It proceeds ways slower than I expected it to do. But I'm writing. So if you're interested in that, you can subscribe on that. And so